Polynomial functions and equations, lesson 10, so last one. Polynomial functions with a leading coefficient other than the 1. So that's when we have that 1 in front. A couple of you guys struggle on your review a little bit because we haven't been talking about those as much because we haven't done the lesson yet. But on your review, there's a couple ones where you have to think about it. We know just through our transformations and the things that we've done, we know that A in front affects what? It affects your vertical stretch, right? So if it affects your vertical stretch, then is that going to affect your y-intercept? Yes, because that's a vertical landing spot. So if you have a, if you multiply your zeros and you get, let's say, -10, but the A is 2, it's really -20. So you have to make sure that that vertical stretch does affect your y-intercept. There's a couple of questions I helped Maddie with this morning during the morning session she was struggling with because that A, we hadn't talked about it yet, that does affect your y-intercept change. Okay, it's going to stretch your y-intercept. Okay, so we'll get to that. So in lesson 7, we introduced the unique factorization theorem, which states that every polynomial function degree greater than 1 can be written as the product of leading coefficients c and n. So here's the leading coefficient, and then here's your zeros. Okay, this theorem implies 2 important points. Every polynomial function can be written as a product of its factors and leading coefficient. Remember, we talked about that even with imaginaries. So we can write it that way even with imaginaries, which we don't get into. And every polynomial function has the same number of factors as its degree. Okay, the factors may be real, complex, and may be repeated. Okay, so complex would be your imaginaries. In lesson 7 through 9, we've considered only polynomial functions where leading coefficient was 1 or -1. This one, we're going to look at ones where we do have a c. So for this one, let's look at this guy. All right, so it says the graph of the third degree polynomial p of x is shown. The graph has integral x-intercept. What does integral mean when it says something like that to you? You're close, yeah. Nope, not fraction. That's actually what it doesn't mean. It means plus or minus whole numbers. It means plus or minus whole numbers. And the reason, but that's good. That's good. So the reason that's important is they're saying that you can assume that that's -1, that's 0, and that's 3. So it's letting you know it does go right through the whole numbers. Okay, so that's what that means. Okay, explain why the equation of the polynomial function can be written in this form. So what we need to do is that we know that 0, that's a 0. -1, that's a 0, and +3, that's a 0, right? And so then what we have to do is, well, what is c? Okay, what is c? So the reason it can be written this way is because we have 3 zeros of 0, -1, and 3. Okay. And then what it says is, use the point of 2, -24 to determine the value of c. And I see a lot of you guys like avoiding doing this for some reason when you're asking questions, is that we got to be able to solve the algebra stuff. The algebra stuff, once you get to plugging in and solving, you should be comfortable with that. And so what I'm saying is that 2 goes where? For the x's. And then where's -24 go? Yeah, for that, right? That's the output. And so then when you do that, notice the only thing left is what? C. And so you're just solving for c now. Okay? So when you're solving this, it's going to be -24 equals c times 2. 2 plus 1, I'm just going to write the numbers. 2 plus 1 is 3, and then 2 minus 3 is -1. And this actually kind of gets simple pretty fast, doesn't it? Because -24 equals -6c. 2 times 3 times -1. And so then we can see that c is 4. Okay. So then it wants me to write it in expanded form. So it wants me to FOIL it out now with the 4 as c. So what you're going to do is just make that a 4x. Okay, and let's go ahead and FOIL that out. So the x plus 1 times x minus 3, that's what I'm doing right now. I'm going to write the 4x here. And when I FOIL x plus 1, x minus 3, I should get x squared minus 2x minus 3. And now I'm going to distribute the 4x in. 4x cubed minus 8x squared minus 12x. So there's no constant. What's that mean? There is one, but it's 0. So you're on the right track, Ollie, but it's 0. Okay, so there is the y-intercept 0 because there's no constant that moved up or down. Okay, and that's why you can see this one definitely is, that's correct. Goes through 0. Okay. We can also see again what we talked about in the warm-up. This one starts low, finishes high, so that's a positive leading coefficient. We have a positive leading coefficient. See? Okay, it's going the positive direction. Okay, any other observations? They are all straight throughs, aren't they? They're all straight throughs. We don't have any multiplicities. We don't have any points of inflection. Because look, the way you can tell if you're saying, I'm not sure how to know if it's 1 versus a 3. Well, look, this one goes straight through. This is concave down. This is still concave down, and it's still concave down through the point. So there's no twist or anything there. And so then we're here. This one concave down, doesn't shift till down here. And then we come up here. This one just straight through as well. So they're just straight through all 3. Okay. All right. Keep going here. We pretty much just have, yeah, 2 pages of examples is all. All right. Let's look at this one. Okay, the graph represents a polynomial function of lowest possible degree. The intercepts in our integers. Determine the equation of polynomial in factored form. So what they're telling you is remember how I talked about one lesson ago when I saw you guys last week, was that it could be a 3 or a 5, but they're saying lowest possible. So your lowest possible means that all those factors are 1, 2, or 3 multiplicities. 1 straight through, 2 is a bounce, 3 is a point of inflection. Okay, so look at these. This right here is a clear point of what? Inflection. You see the twist, see? Concave up to concave down for -2. So I know right now I'm going to go x plus 2 cubed. That's going to be a factor. Has to be. Okay. And then this is a straight through. Right? So then that means this one would be x minus 2 just by itself. Now the thing we don't know in this case is still c, right? We don't know if there's a leading coefficient. And notice it tells me the key thing again, they says the intercepts are integers. That means all intercepts. So it's saying the x's. What's this value here? Well, be careful. 2, 4, 6, 8, 10. This is going by, no, it's going by, what is that going? 4s. 4, 8, 12, 16, 20. So those are going by 4s. Be a little tricky. So our y-intercept is -8. The reason that's helpful, that gives me a point to solve for c now. I can now solve for c. What's that? The c? Oh, we'll talk about it. This one will, and you'll see, like, because we really have 3 of these, right? And so this is actually, no, sorry, this one's actually too big. So I'm just kind of going to what Cash asked here is like, remember, we can get our y-intercept by multiplying the constants of our factors, right? So there's 3 2's here, right? That's an 8. And then another -2, that's a -16. So this should be, just by that, what should c be? 1/2. We're expecting it to be a half. Okay, so let's see if that happens. Does that make sense? Let me say that one more time. There's 3 x plus 2's here. So if I wrote this all out, this is tedious, but just so you can see it, we know that 2 times 2 times 2 times -2 will be a constant. That constant in this situation is -16. We're at -8. So the c adjusted that -16 to -8 by halving it. So we're expecting c to be a half. We're still going to do the work, but we're expecting c to be a half. So to do that, put zeros in for your x's, solve for c. So -8 equals c times 0 plus 2 cubed, so 2 cubed, and 2 minus 2 is 0. No, sorry, 0 minus 2, thank you. That would have been a bad mess up. Okay. So that's 8 times negative 2, so negative 16. Negative 8 equals negative 16c. Divide, divide. You can see we get the 1/2. So 1/2 is c. So your complete equation for this would be y equals 1/2 times x plus 2 cubed times x minus 2. Any questions there? Okay. All right. All right, so we go to the second example here of this page. Determine the equation in factored form of a 4th degree polynomial which passes through 1, negative 12, is tangent to the x-axis at 2, 0, and negative 3, 0. So that means it has 2 bounce points. You reading that okay? It's got 2 bounces points. It says it's tangent to the x-axis at 2, 0, and negative 3, 0. So to determine the equation. So just so we don't know c again. And this is like with parabolas. Parabolas, you give vertex and a point. We solve for a. This is the same type of thing. So this is x minus 2 squared, and then it's x plus 3 squared. This is what we have so far. And so again, that point's important because my x and my y, and I can solve for c now. So that 1, negative 12. So negative 12 goes in for the y. We have c. We have 1 minus 2, so that's negative 1 squared. And then we have 1 plus 3 is 4 squared. Okay. So negative 1 squared is nice. It gets rid of the negative. So that's going to be 1. 4 squared, 16. So it's 16c equals negative 12. So c is negative 3/4 when you simplify the fraction of 12 over 16. Okay. Okay. All right, last page, and then we'll be done. Okay, 4th degree polynomial passes through the point 1, 2, and has its zeros of negative 1, zeros, 3/2, and 2. So 4th degree, so all these zeros are, they must be straight throughs because there's 4 of them. Okay, so that means, and then if that's a 0, so if this is a 0, that's the y-intercept, okay, because 0, 0. But anyway, let's look at all this stuff. So zeros are x minus 1, so x plus 1 is a factor. Then we have an x out front for the 0. How do we get 3/2? You guys remember? Good. 2x minus 3, and then 2 would be the x minus 2. So there's your zeros. Okay, and we're going to solve for c again. Bless you, bless you, bless you. Okay. Again, it gives me that point. This is very important. It gives me this point. Okay, and some people in the past, when I've taught this material, is they plug in the zeros. Why is that a problem? So you plug in the 0, everything's going to go away, right? Because this whole thing's a product. So if you plug in one of these guys, it's going to make the whole thing 0, and you're going to be, well, what's c? Because c just got axed out. Okay, so you need a point that's not a 0 to plug in. And I'm talking, y-intercept's okay, right? Because that's not an x is 0. That's a y is 0. Okay. Okay, so, or excuse me, that's an x is 0, but not a 0 in terms of x-intercept. Okay, all right, so we're plugging in 2 for y. We're plugging in 1 for x. 2 times 1 minus 3, so that's negative 1. Sorry, there's c right here too. Forgot the c. And then we have 1 minus 2, another negative 1. Okay, so 1 times 2 is 2. Got 2 negative 1s, a positive. So essentially, it's going to be 2 equals 2c. So C is just 1. So that means there actually isn't a coefficient, right? If you get 1, there actually isn't a coefficient different than 1, which is okay. That can happen. So your actual answer is just simply, we can just erase this. That's the answer. You can put a 1 there if you want, right? But no point. Okay, any questions? Got the last one here. It's going quick. Okay. Last one. All right, I like these ones. Okay, so polynomial equation has the following 3 roots. A -2 is a root with a multiplicity of 1, 1/3 root multiplicity of 2, and 1's a root of multiplicity of 3. The graph of the corresponding polynomial function has a y-intercept of 2/3. That's important because this is a point. This is the point that's not part of the zeros you want to use. This is the 0 2/3. Okay, determine the equation of a polynomial function in factored form using the integral factors. Okay, so we need to write out first, and we're still solving for C, so nothing's changed. So we're going to say our p of x, our polynomial, is C times x plus 2. So 1/3, how do we get 1/3 again? 3x minus 1, and it has a multiplicity of 2, so squared. And then we have 1 is a root with multiplicity of 3, so that's x minus 1, multiplicity of 3. And so now we have it built. Okay. So we are going to plug in 2/3 here, C times, and we're going to plug in 0 for the x's. 0 plus 2 is 2, -1 squared, and -1 cubed. So when you simplify that, you're going to get 2/3. So you got, that's positive, but that's negative, so you're getting a -2c. So 2/3 divided by -2 is, good. You're halving 2/3, right? Dividing by 2 means half. Half of 2/3 is 1/3, but with a negative. So C equals -1/3. Good. And so your final answer, this one, just take the beginning and we write what we know for C now. So the final function here is -1/3 x plus 2, 3x minus 1, and x minus 1 cubed. Okay, that's a minus here. Okay, that's it.